Hello guys, so today we'll be trying to make this pretty simple sketch. So it's just a Bezier curve, quadratic Bezier curve. Sorry, a cubic Bezier curve. um, so this will be the first video on this topic. We will try to make subsequent video where we might want to add points following these points, right? So yeah, that's pretty much it. So in the end, after all of the videos, we'll try to have a spline basically. So let me get to the whiteboard and explain the principle behind this specific curve. So let me take a marker. Awesome. So yeah. So let's say we have our canvas, right? Right here. We will need four points, right? So P1, P2, P3, P4, right? Give me 1 second. All right, sorry. So yeah, we'll need 4 points to start with. These are going to be XY coordinates, right? Into our canvas. We need to remember also this is the 0, 0 point, right? And this is with height point. So these are the first 4 points that we will need, right? This is not pretty. All right, let's make this a little bit better. Awesome. So first. Okay, great. So let's select 4 points, right? So over here, and let's say over here. Doesn't matter. This is P1, P2, P3, and P4, right? So the order is important here, right? So the goal is to create a curve between the 4 points, starting at point 1, ending at point 4. So the first thing first that we need to do is we need to understand that we will need to create lines between we'll need to create separate points between those 4 lines, right? So let's say we wanted to get to the middle part of our line, right? So let's say we have our line and we want to get to the middle point in our line. So we know the middle is 50% of of the line, right? 50%, right? So that means we need to find out 3 other points. I'll call them P5, P6, and P7. These points will be at 50% between, so point 5 will be at 50% between point 1 and point 2. I'll say 50%. And the same apply for the other 2, right? Those ones are going to be point 2 to point 3, and then point 3 to point 4. Okay, so let's try to make this, right? So we can estimate the 50%. It's about over here for point 1, point 2. So this would be our point 5. Well, let's do point 3 and point 2. So it's about here, I guess. This is 0.6. And then 50% between those two, let's say about here. Yeah, P6, P7, right? Awesome. But we're not done yet. We need to get to a single point. Right now we have 3. We started from 4, now we have 3. We need to get to 2. So if you can guess it, to get to 2 points, we need to get the 50% between this one, and this one, and this one. Then we would have 2 points, right? So let's do this. So second, and this would be third. Let's say 0.8 and 0.9. Awesome. So 0.8 would be 50% between those 2 points. So between 5 and 6. So between 5, and 6. I won't put 50%, but it's going to be whatever percent we want at. And 0.9 is going to be between 6 and 7. Awesome. So let's estimate it. So about over here and about over here. So this is P8 and P9, right? Okay, awesome. Now we have 2, but we wanted one single point. So again, we do the same exact thing. So P10 is going to be the middle point between 8 and 9. So between P8 and P9, right? So that's pretty much it. So P8 and P9. So this is our P10. So this point right here is the middle point of our line that goes from P1, of our curve that goes from P1 to P4, passing, well, using P2 and P3 as well. Okay, awesome. So we know the middle point. Now, how can we get our curve from just the middle point? We would need more than just the middle point, right? So let's say I'm going to erase this just because there was a lot of writing on there. So I'm going to keep P10 and the original 4 points, right? Going to even erase P. There we go. So again, now let's say we wanted it at 10%, right? So 10% now. So this is 50%, right? So 50%. So 10%, let's say 10% would be over here somewhere, 10% would be over here, 10% would be over here, right? So, okay, and now we need to do it again, right? So 10% between those two, about over here, I guess, maybe even a bit closer to this one, maybe over here, 10% between those two, so maybe over here, and 10% between, no, that's it. So now we have those 2 points, and we need 10% between those two, which would be over here, right? So we have our 10% point. Let me erase the other ones. So this we don't need. There you go. Awesome. So now this is the 10% mark. Let's do 80% now. Okay, 80% between P1 and P2, right? So about over here, I would guess, right? About over here, maybe even a bit closer to 1. Okay, maybe about over here, right? This 80%. And P2 and P3, maybe 80% is about here. And P4 and P3, maybe 80% is about over here. Now, let's do it again. So 80% between those 2 points. Well, I would say it's onto the 50%. I'll just put it right here for the moment. And 80% between those two would be, let's say, over here. And now 80% between those two would be over here somewhere, right? So this is our 80%. Awesome. So now we have something to work with. Let me erase, not sure if you can read it. Yeah, that's fine. So let me erase the other points that we don't want. Awesome. And let me draw what we would have from a line. So 0% would just be our P1, and 100%, oh, you cannot see. Well, 100% would be our P4, right? So we have right now for our curve, we have 1, 2, 3, 4, 5 points. That's pretty good. That's a bit small, this number, but let's see. So we go to 10%, we go to 50%, and then we go to 80%, and then we go to 100%. So if we interpolate this more than just 3 times, and we do this, let's say 100 times, we would have a much more smoother curve that would give us this, right? The actual, it would be curving visually. Right now it's not, since we selected not that many points, but that's the whole principle behind it, and doing it more than just 3 times, right? Doing it maybe 100 times or maybe even 50 times, depending on the length of the actual curve. It might be better to have more or less, but let's try to do at least this, right? So, and we can see it here as well, right? So it's at any point in time, it's just oh, okay, now we're at 30%, 40%, 50%, so on and so forth, right? So if I were to match up with what we had previously, so this is P1, P2, P3 was over here somewhere, right? And then P4 was over here somewhere, right? That looks pretty similar to what we had, right? So that's the goal. That's the end goal. So let's start this. Let me erase what I had. Okay, awesome. So we know we first need 4 points, right? So let's get those 4 points out right away, right? So we'll select 4 random points. I'm fine with that. Let's do a size of, I don't know, maybe 800 by 800. Awesome. Let's do a background, not black, but pretty dark. Okay. Okay. And then let's select 4 points, right? So, and we're going to use p vectors since they contain x and y. It's just easier instead of p1x, p1y, so on. So let's do that. So new p vector, and there you go. And we'll select between random 0 and the width. And let me do like between 100 and width minus 100, just so that they're not on the edge, right? And let's copy this and put it for the height. Awesome. So we're done with P1. Let's do the 3 following points. So it's going to be the same. Random selected points on the canvas. Awesome. So now we have our 4 points. I think I want something like Bezier or curve and pass. Oh, curve seems to be something by default. Let's select Bezier. So Bezier and passing the 4 points, right? P1, P2, P3, and P4. That's what I would like. So let's create that function Bezier. This function is the one that is going to know, like that is going to compute all of the 10 points, right? Minus the 4 initial points, right? So let me copy this, put this in here. It's going to receive 4 points, which are all going to be p vectors. Awesome. So P4, P3, P2, and P1. Okay, great. So we said let's do it 3 times, just like we did, right? So for I is equal to 3, int I is equal to 3. Sorry, it's equal to 0. I is and yeah, let's do int count, right? The count of time we want to go and do it, right? The amount of points that we want. Yeah, I don't know. It's fine. So so 0, we already know this would just be P1, right? So we can just omit this and straight away go to 1, right? So we'll say as long as I is less than our count, and count plus 1 even, because the 4th point, well, the 5th point, the point at where I is equal to our number that we want, we'll know that it's the 4th point, right? So we'll do it manually. We'll add the vertex manually. So let's do this. So we already have P1, P2, P3, and P4. If we look back at our whiteboard, we need P5, P6, P7. So let's first go with those. So we need P vector for P5, P6, P7. Let's do P5. New P vector goes. Okay, so now we need, like we said on the whiteboard, we need to find the value, the middle, well, not necessarily the middle, but the value at whatever percent we're at, the point between those 2 points at x percent, right? So let's do the percent. So we know, let's call that maybe amount, right? At which amount do we want it to be? It's going to be a decimal number, or 1 or 0 exactly. In our case, should never be those. Let's do it. So it's going to be I divided by the count plus 1, right? I think. Yes. Well, we'll see. And what I'll do is I'll just convert the I to a float, because we do need the floating value to be computed and not an integer. Okay, great. So we need to lerp between p1.x, p2.x, and at that specific amount. And that's for the x, and we need to do the same but for the y, so p1.y and p2.y at that same amount. That should be it for the 0.5, right? And I'm going to streamline this function, well, this thing, just because we're going to do it like 1, 2, 3, 4, 5, 6 times just in there. So it's going to be a little bit easier if we have a function to do that. So it's going to return a p vector. We can call that lerp vector maybe. So lerp vector is going to receive p vector p1 and p vector p2, right? And it's going to return exactly what we had. Oh, it's also need to receive an amount, right? Amount, which is going to be a float. Awesome. So let's remove this and use our lerp vector function with p1, p2, and the amount. Awesome. Okay, so we have p5, we need p6 and p7. p6 and p7. So p6 is going to be from 2 to 3, and from 3 to 4. Okay, great. So now we have our 3 points. From 4 to 3, like we had over there. And then the third phase is from 3 to 2, right? From 3 points to 2 points. So we need P8, which is P5 and P6, and P9, which is P6 and P7. Let's get right back into it. So let's copy this 2 more times. So P8, P9, we said from P6 to P7, and P7 to P... No, sorry. Yes, no, from P5, right? Yes, P5 to P6 and P6 to P7. P7, there we go. Yes, that makes sense. Then the last thing that we need to do, if we take a look back at the whiteboard, let me get there. So it's going to be from 2 to 1 to the single point that we want, right? So in our curve, right? So this will be the point in the curve. So let's call it P10 just because we're on a roll, and it's between the last 2 that we did. So P8 and P9. Okay, now great. So let's draw a point at that point, right? Let's draw a point at that point. That's cool. That's a great idea. Awesome. So there you go. We're done with this. Let's try to run this. Okay, I'm not seeing anything, right? So let me do something like set the stroke to white. Set the stroke weight as well to maybe something like just I want to see them, right? So maybe 10, and then no fill. Well, no fill doesn't really matter. Let's try it out. Okay, so we have one single point. That's as expected, but I'm not seeing the other points. So let's just show the other points as well, right? Just because I want to know from where we're starting, right? Like what's the 4 original points, right? So let's do a stroke reddish, 90. There we go. I don't know. And let's do point from p1.x and p1.y. Let's copy this, duplicate it 4 times, well 3 times. So p2, p3, p4, p4, p3, p2. Awesome. And let's also move the stroke weight to here. Okay, awesome. Let's see this now. So it's a bit difficult to judge, right? I mean, okay, here I would be expecting the point to almost be in the middle, right? Or well, I mean, wait, we're expecting 3 points. I'm only getting 1 right now. We have an issue somewhere. What's that specific issue? Right? Oh, I also want to do this and this, since over here we will have the first point be P1, P1, and the last point being P4, P4. Okay, see this again. We have 2 points, which are first one and the last one. That makes sense. But then this does not make sense. Let's console log, let's print the amount just to see if we get something that we're not expecting. So we get, oh, okay, so we're not getting a percentage, right? We're getting 1, 2, we want something like 0 point something, right? So I, which is, okay, divided by count, which is +1, count, +1. Does that make sense? That makes sense. The count +1. Oh, wait, you know what? Okay, that makes more sense. Maybe let's comment these out because we're already drawing them for right now. Okay, great. Let's see this now. Oh, let me do this instead. Sorry. Yeah, there you go. Okay, so we have 3. Okay, that looks good, right? So if you think about it, let's say we start from here. This is P1, this is P4, P2, and P3, right? So let's say we were to draw a line between like that, use those 3. That seems to make sense to me. Let's actually draw the line, right? So instead of a point, we can use begin shape, end shape. So begin shape, end shape. Let's change point for vertex. Let's see now. Okay, though I will want to have the vertex for both this one and this one, right? P1 and P4, because they were not accounted for in the loop. So we can just do them because we could do them in the loop, but I rather have them not in there since we don't need to do the calculation for those, since we already have those. Okay, great. I'm going to say no fill. I don't want to see the inside. Okay. Okay. I mean, I think it's starting to look good. Maybe change the stroke weight to, whoa, to 1 after we've drawn the original point, or 2, maybe 2 is fine. There you go. Okay, I think we've pretty much got it. Let me change the count to maybe 30, right? So that looks good. Let's say P1, P2, P3, and P4. It's trying to get to P2, and then P3, and then P4. Awesome. I mean, let's run it a couple of more times, right? That looks good. So from P1, trying to get stretched out to P2, trying to come back to P3, and then to P4. Awesome. We're pretty much done. That's pretty much it, really. Yeah, so that's it. What you could do is maybe put all of this in, move all of this in the draw function, right? And moving this in the draw function won't change anything, just looking at it. We'll need also the background. Okay. And let's say point, just because we already have, I'm going to make those global, but since we already have variables named P1, P2, and P3, it's going to be a bit like from our attributes over here, right? It's going to be a bit of a problem if I name them the same thing, right? P1, P2, P3, and P4. P1, P2, P3, and P4. Awesome. Let's remove P vector. We don't need that anymore. Okay, great. And over here, we're going to pass point, 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 and point, right? Oh yeah, over there as well. Sure. Whoa. P1, P2, P3, P4. And you could make this into a class. We will probably make it into a class next time we revisit this, those lines. For right now, it's fine though. And since we've added it into the draw loop, now we could possibly do something like on mouse, maybe one point is following the mouse, right? So maybe we can say point 2, set, and we can set the value of x and y to the mouse x and mouse y, just to see. Okay, so let's see. Yeah, this looks good. So it's stretching, it seems to be doing exactly what we wanted it to do. Okay, great. So that's pretty much it for the sketch for today. Though eventually we'll come back and we'll try to add more points to this, and see how we can possibly make an infinitely continuous line curved, using the cubic variation of the Bezier curve. So that's it for today. Hope you liked the video. Subscribe and share it to people. Share me what you do with this. It would be really nice to see. And see you in the next one.